Good morning, calculus class. Sorry that I cannot be with you this morning, but I am with you in spirit. So we're going to go through two topics today quickly. If the sub needs to pause the video at any time, please speak up. First thing I want to talk about today is the average value. Okay. If we take the area and we sum it up, and then we divide by the distance of our interval, b minus a, then we get the average y value of the function on that interval. So we're going to do a couple examples here. The first one, we want to find the average value of 3x squared minus 2x on the interval from 1 to 3. So f of x is 3x squared minus 2x, and our interval is 1 minus 3. So, we're going to take the area from 1 to 3. And then we're going to divide by the length of the interval. So we're going to multiply by 1 over b minus a. Okay? So essentially, we have 1/2 times this integral. So we can use the fundamental theorem of calculus that we used yesterday. So we can take the antiderivative. The antiderivative of 3x squared would be x cubed, minus the antiderivative of 2x would be x squared. And we're evaluating that from 1 to 3. So we have 1/2 times the quantity. We have 3 cubed minus 3 squared. And then we're going to subtract when we plug in 1. 1 cubed minus 1 squared. So here's where we plugged in 3, minus here's where we plugged in 1. Okay, that's what we did yesterday. So, if we take 27 minus 9, we get 18, minus 1 minus 1, which is 0. And we have that times 1/2. Our average value is 9. Okay. So what that means is on our interval from 1 to 3, our average y value on our function 3x squared minus 2x is 9. Our average height is 9. We're going to do one more example of this topic. And this time we're going to go a step further. We're going to find the average value, and then we're also going to find the x value in which that occurs. So please write down the function f of x is x cubed, and then write down the interval 2 to 4. So we are going to take the area under the curve, and then we're going to divide by the length of our interval. So we have 1/2 times the integral from 2 to 4 of x cubed. So if we take the antiderivative, we have 1/4 x to the 4th, evaluated from 2 to 4. So I'm just going to leave this 1/2 out here. I'm going to evaluate my antiderivative from 2 to 4. So 1/4 times 4 to the 4th minus 1/4 times 2 to the 4th. So 4 to the 4th divided by 4 would be 64. 2 to the 4th divided by 4 would be 4. So we get a value of 30. Now remember, this is representing the average value, as in the average y function value, so our y value, okay? So up here, it is asking us to go ahead and find the x value at which that occurs. So we know that our average height, our average value, is when f of x is 30, okay? We want to figure out the x value, then we need to say, okay, x cubed equals 30. So our x value is the cubed root of 30, all right? So we have an average value of 30 when x is cubed root of 30. Okay, you have, if you look at your gold sheet, you don't have to do that right now, but when you look at your gold sheet, you will see that there are 2 different book pages that your assignment comes from. One of them will deal all with average value. Okay. The other will come from the section with U substitution. So I'm going to go back. Okay, if I would have been there today, one or all of these would have been your problem of the day. But what I'm going to go ahead and do is, where's my screen shade? Here it is. I'm going to go ahead and have you do this problem as kind of a warm-up into our substitution. So I'll go ahead and have the sub pause it for a moment while you work on finding this antiderivative, and after a couple minutes they will push play to continue. I do not mind if you work together, but I'd like you to get this antiderivative. Okay, so this is one that we have done before. If we flash back to like last week or maybe a week and a half ago, since we had all those that snow day. Remember, if we have a composition times a function, we can try U substitution. So in this case, you can let U equal x squared plus 1, which makes du 2x dx. All right. So since we have a 2x dx right here, we can replace it with du. And x squared plus 1 to the 50th becomes u to the 50th. Okay. Well, that antiderivative is 1 over 51 u to the 51st plus c. But then remember, we have to change it back into x's. So 1 over 51 times x squared plus 1 to the 51st plus c. Okay. Remember, if we have an indefinite integral, we have to have that plus c. Once we have those limits of integration, we're going to get a numeric value. We don't have to have that plus c. Okay, and that's what we're going to do today. We're going to use the fundamental theorem of calculus that we talked about yesterday, and incorporate it with our method of U substitution. So here is our first example. Please write this down. All right. You can see that we have a composition times another function. And so this is a good candidate to see if U substitution will work. Okay, you don't want to multiply that x squared plus 1 to the 5th out in order to use the power rule. So we can let u equal x squared plus 1, which means du is 2x dx. Okay. Conveniently, we have 2x dx. So this becomes the integral of u to the 5th du. Now, for right now, I am not going to put the limits of integration on my integral because those are in terms of x, and right now our variable is u. So right now I'm going to leave them off until I get my antiderivative. Okay. So our antiderivative of u to the 5th would be 1/6 u to the 6th plus c, right? But we have a definite integral. Let's not worry about that plus c. What we can do now is we can change this back to x. What we have is 1/6 x squared plus 1, and since this is a definite integral, this is evaluated from 1 to 3. Oh, forgot my 6th power, sorry. So you have 1/6 x squared plus 1, the quantity to the 6th power, and that is being evaluated from 1 to 3. So we have 1/6 3 squared plus 1 to the 6th minus 1/6 1 squared plus 1 to the 6th. So we take 10 to the 6th minus 2 to the 6th. So I'm getting 166,656. Okay, now I am going to teach you how to do something on your calculator, and for the purpose of today, you are going to use it to check your answers. There will come a time where you can use it to actually get the value, but right now we are going to use it to check our answers. Okay, and I'm going to show you how to do this on your calculator. So come time when we need to do these with our calculator, we'll know how. All right. So now I know most of you have 84s. It's going to be the same, okay, but nicer. Okay. So what you're going to do is you're going to go to math. Remember, 8 was our derivative. Math 9 is our integral. So if you have an 83, you're going to get this prompt. If you have an 84, you're going to actually see the integral symbol. Okay? So if you have an 83, you're going to go ahead and type in the function, and then you're going to put a comma. We want to do this in terms of x, comma, and then we want to go from 1, comma, to 3. Okay, so if you have an 83, you're putting in the function, then you're putting in comma x, and then you're putting in comma a, comma b. If you have, Mrs. Holman did not put her function in correctly. Sorry about that. Okay, we're going to start over here. So we'll go through this again. Math 9. Plug your function in. X squared plus 1 to the 5th times 2x. That's what I forgot. Comma x. You have to tell it what variable you're with respect to. Comma a, comma b. Okay. So if you have an 84, it's going to look exactly like what you see, over here. And so you'll plug in 1, then you'll plug in 3, then you'll plug in your function, and then you'll have to fill in the x if you have a TI-84. Okay? So it's the same process, but much simpler. Okay? All right. Now, I want to come back, and I want to do another example here. The same example, except this time I want to show you how to change the limits of integration. Okay? So when we did this, we said, okay, u is x squared plus 1, and du is 2x dx, right? We then wrote that this is the integral of u du, u to the 5th du. There we go. Now, what we can do, because over here we just left off the limits of integration, and then we put them back on once we switched over to x. What we can do is, since this integral is in terms of u, we can put our limits of integration in terms of u by using this rule that we wrote right here. So if u is x squared plus 1, well, our lower limit is x is 1. So if we plug that in, we get that our lower limit for u is 2. Our upper limit, x is 3. So if we plug that into x squared plus 1, we get u is 10. So now what we can do is we can take the antiderivative, and now we can evaluate in terms of u. So we have 1/6 times 10 to the 6th minus 1/6 times 2 to the 6th. And then we can get our 166,656 that way. I'm going to be pretty flexible. I don't care which way you go about it. Either way, it's going to be the same amount of calculation. Here, you're plugging into u first, okay? Where back here, when we rewrote u in terms of x, then you're doing those same calculations, okay? So let's do one more. We'll go ahead and change the limits of integration to get that practice. But if you don't want to, if you want to change it back to x and then do your limits of integration, then you can do that in your notes. And we should still come to the same answer. Okay, so let's do this one. The integral from 1 to 3 of x squared times 4x cubed plus 1 the quantity to the 4th dx. So we can let u equal 4x cubed plus 1, which means du is 12x squared dx. Now, we have the x squared dx, but we don't have that 12. So remember, we're going to have to divide that 12 over to be with the du to use as our substitution, okay? So now we have x squared dx to replace. So this is going to become the integral. I'm going to go ahead and throw that 1/12 on the outside, so 1/12 du, and then we have u to the 4th. If you want to change the limits of integration now, let's go ahead and do that. Okay, so we're going to use this rule right here. So our lower limit of integration is 1. So 4x cubed plus 1 is what u is, which means we're going to have 5 for our lower limit. Our upper limit is 3. So u is 4x cubed plus 1. So our upper limit is 109. Okay? Now all we have to do is take the antiderivative and evaluate. Okay? If you want to take the antiderivative and then change back to x so you can still use 1 and 3, go for it. Okay? So we have 1/12 times the antiderivative is 1/5 u to the 5th, and then we need to evaluate that from 5 to 109. Okay, I'm going to go ahead and rewrite this as 1/60th, and then we're going to have u to the 5th minus 1/60th u to the 5th. Oh, I don't know what I wrote here. There we go. This is what I get in my calculator when I do that calculation. Let's go ahead and with our calculators practice that Math 9 command. So we can put Math 9. Our function is x squared times 4x cubed plus 1, the quantity to the 4th power, with respect to x from 1 to 3. Sometimes it takes a little bit to think, but there it is. What I would like you to do is I would like you to try this one. I don't want you to use your calculator, and I want an exact value. So I'll go ahead and let the sub press pause, and after a few minutes, after we think everyone has it, then the sub can press play, and you can see the answer. Okay, so you should get 1/3 cubed root times the cubed root of 8 minus 1/3 times 1. So you can write it like this, or you can factor out the 1/3. Okay, that should be your answer. Okay, if you had trouble getting there, this is what I should see. You should let u equal x squared plus 1, which makes du 2x dx. We only have an x dx, so you're going to have to move that 2 over. So this becomes the integral 1/2 integral of u to the 1/2 du. If you were the person that changed your limits of integration, your lower limit would be 1 and your upper limit would be 2. So we have 1/2 times our antiderivative of u to the 1/2 is u to the 3/2 times 2/3, evaluated from 1 to 2. Those cancel. So you have 1/3 2 to the 3/2 minus 1/3 1 to the 3/2, which is how we get that answer. Remember, I'm not picky about simplifying. Square root of 8 is perfectly fine. Okay. So, look on your gold sheet, but you should have 2 homework assignments similar to this. Whatever's on page 298 is your U substitution. Whatever's on 285, that is your average value. For the remainder of the period, please work collaboratively, but you need to be working the entire time. I will see you on Monday.